Let's look at this. Find the end term of this sequence. The end term of this sequence. How do we go about this? This is another end term. A formula to represent this pattern or this sequence. But you need to investigate the pattern. What is going on here to get that formula? How do we go about this? The first thing you need to do, you recognize the first one, 32. This one is coming from here. So therefore, we are going to put 32 here. But how can we use this 32 that is coming from here to get 16? You agree with me, it's divided by 2. Okay? For this third one, we must still recognize this 32 over 2. But how can we use this 32 over 2, which is 16, to get 8? Is to divide it further by 2 to have 8. Then we must still put this one here for the fourth position. How can we get 4 from here? To further divide by 2. Now we have a pattern. But the problem with this pattern is all of them have divide by 2, at least 1 at the denominator. But this one does not have. We have to force 2 here. To remove this 2, because it is not here originally, I can just simply put raised to power 0, which is 1. 2 raised to power 0 is 1. It means I am not changing this original value. What I've succeeded in doing is forcing 2 here to resemble all this other denominator. But because of this power, this guy is also hungry for that power. So your own is power 1, okay? Don't be hungry. Your own, because you are 2 in number, is power 2. Your own, because you are 3 in number, is power 3. Therefore, to get the end term now, I have to follow this pattern to say the end term is 32 over 2 is common, because this 32 is common for all of them. I put 32. Over is common. 2 is common. Then this power is not common. There is a change. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. Therefore, here we put n minus 1. This is what? The pattern for this one. If you want to simplify this, you can simplify it. But this is okay, okay?